Hey guys, welcome back. Hope you all are absolutely fine. As you know that we were studying chapter first of class plus 2 solutions, and in the last topic or in the last lecture we have studied the methods to find the concentration of solutions. In that we studied molarity, normality, formality, mole fraction, mass percentage, volume percentage, strength, and so on. Huh? Okay. And we also did the numericals related to that. Hope you all have understood the last topic. If you have any queries or questions related to the last lecture, you can please text me. Okay. So moving on to next topic. The today's topic is vapor pressure of liquid. Before going to the vapor pressure, we will study some basic knowledge. That is, we will start with evaporation of liquid. What is evaporation? As we have done in the lower classes, that evaporation is a surface phenomena. Evaporation is a surface phenomena in which the liquid changes into vapor state from surface. In which the liquid changes to vapor state from surface. That's why it is known as surface phenomena, and this is known as evaporation only. Okay. Now, what is the cause of evaporation? The motion of molecules, the intermolecular collisions are the main cause of evaporation. As you all know that suppose this is a beaker in which a liquid is kept, suppose water is kept in this. So there are a number of particles of that solvent or that liquid in the beaker, and they also have interparticle forces of attraction between them, and they also have motion because they also always move in a random motion, right? Now molecules present on the surface, जो molecules surface पे होंगे बेटा, they have sufficient kinetic energy. When they have sufficient kinetic energy, and from where they got the kinetic energy? From the molecules present inside the liquid, in the bulk of the liquid, because this part is known as bulk and this is known as surface. Clear? So the molecules present in the bulk, because they are constantly or randomly moving, when they will collide with the molecules present on the surface, they will provide some energy to the molecules present on the surface, and the molecules on the surface possess sufficient kinetic energy so that they can overcome the interparticle forces of attraction, and they will leave the surface and evaporates. Okay, or changes from liquid into vapor state. So this is how evaporation occurs. Okay, but in a closed vessel, if the vessel is closed, then it will not evaporate. तो वो बाहर तो जाएगा नहीं, it will not leave the container, है ना? तो क्या होगा बेटा? In a closed container, so in a closed container we can say that the liquid and the vapor always present in equilibrium with each other, है ना? And when the liquid changes into vapors, it is known as evaporation. When the vapors again changes into liquid state, it is known as condensation. And we will say that an equilibrium will achieved in a closed container between liquid and its vapors. And also what we can say that at equilibrium or in a closed container, the rate of evaporation becomes equal to the rate of condensation. Okay, so we can say that the rate of evaporation becomes equal to the rate of condensation in a closed container only. Okay, so another thing, next part for evaporation, factors on which the rate of evaporation depends. Factors on which the rate of evaporation depends. What are the factors on which the rate of evaporation depends? There are so many factors on which the rate of evaporation depends. The first one is temperature. As the temperature increases, the evaporation also increases. Second one is surface area. As the surface area increases, evaporation also increases. This we did in the low classes, so there is no, I think, no need to explain it in detail. And third one is density. Greater the density of a liquid or solution, lower will be its evaporation. I'll explain it to you in some detail. The factor density on which the rate of evaporation depends. Now listen, density थर्ड फैक्टर था जिस पे evaporation डिपेंड करेगी. There is a law given by Graham. So according to Graham's law of diffusion, the rate of evaporation is inversely proportional to the square root of density. So rate of evaporation is inversely proportional to the square root of density. If the density of the liquid or solution is more, then its evaporation will decrease. If density is lower, the rate of evaporation will increase. For example, as we know that there are two types of, we can say that, substances: volatile and non-volatile, है ना? तो volatile substances are those substances which can evaporate on their own at room temperature only, because they have very small interparticle forces of attraction. Okay, and non-volatile substances are those substances which will not evaporate at room temperature. They need some energy to convert. We need some energy to convert them into vapors. So they have stronger interparticle forces of attraction. That's why they are non-volatile. And volatile substances are those substances which have weaker forces of attraction. That's why they are volatile. They can easily change into vapor state at room temperature. Okay, so when a non-volatile substance is added or dissolved in a liquid which is volatile, for example, water is volatile, है ना? So suppose a salt or sugar that are non-volatile is added to water, ठीक है, which is a liquid, its density always increases. So if the density increases, then the rate of evaporation decreases. Understood that the rate of evaporation, how it depends upon the density of liquid. Okay, so next fourth one is on which the rate of evaporation depends, that is intermolecular force of attraction, or interparticle or intermolecular forces, we can say it, intermolecular force of attraction, and these are also known as cohesive forces. So cohesive forces are those forces which are present in the particles of the same substance. ठीक है, cohesive forces always act in the particles means molecules, atoms, and so on, of same substance. For example, between the two molecules of water, so both the molecules are of water, so the forces acting between these two, they are known as cohesive forces. Okay, and there is another type of force, it is known as adhesive force. Sorry, there is only one D. Adhesive force. Adhesive force is a force which act between the particles of two substances, the particles of different substances. For example, when we put water in a glass, then and when after that if we throw out the water from the glass and make the glass empty, then what will you see? You will see that there are some water droplets, they will remain attached to the surface of the inside surface of the glass, है ना? Okay, or a container, we can say that. Okay, so अगर हम पानी को एक कंटेनर में डाल दें, किसी गिलास में डाल दें, तो उसको खाली करते हैं बाद में, तो हम देखेंगे कि गिलास की साइड्स के अंदर वाली जो साइड है, जो कंटेनर के अंदर वाली साइड्स हैं, इनसाइडर साइड्स हैं, उस पे वाटर के कुछ पार्टिकल्स या कुछ वाटर अटैच होगा उसके साथ, मतलब गिलास अंदर से गीला हो जाएगा. तो बिकॉज ऑफ वाई वाटर हैज स्ट्रॉन्गर एडहेसिव फोर्सेस विद द ग्लास कंटेनर. ओके, बट अगर उसमें मर्करी डालें, हम किसी गिलास में मर्करी, किसी कंटेनर में मर्करी डाल दें, तो मर्करी अगर उसको बाहर डालने के बाद बाहर निकाल दें, तो वो गिलास के साथ नहीं चिपकेगा और कंटेनर के साथ नहीं चिपकेगा, क्योंकि उसकी कोहेसिव फोर्सेस ज़्यादा है, उसकी एडहेसिव फोर्सेस बहुत कम है. क्लियर? सो दिस इज I think the topic which you have to know, that what is adhesive force and what is cohesive force. So intermolecular force, greater the intermolecular forces of attraction, smaller will be the evaporation. Okay, so जितना intermolecular force of attraction बेटा ज़्यादा होगा, उतनी evaporation कम होती जाएगी. Okay, for example, if we compare ethanol and water, so going from ethanol to water, the evaporation क्या होगी? Decreases, because the intermolecular force of attraction increases. Okay, so this is how it works, evaporation. Now moving on to next topic, that is we are having, that is the main or important one for this chapter and board exams also, is vapor pressure. That what is vapor pressure? Okay, but a vapor pressure in a closed vessel or in a closed container, the liquid and the vapor state always exist in equilibrium. We have done it, you know. Suppose this is a closed vessel, suppose there is a water present inside it, and if we heat it from below, what will happen? It will change into vapors. After some time, the vapors and the liquid comes in equilibrium with each other. मतलब जितने मॉलिक्यूल्स वाटर के कन्वर्ट होंगे वेपर स्टेट में, उतने ही मॉलिक्यूल्स वेपर के कन्वर्ट हो जाएंगे वापस लिक्विड स्टेट में. मतलब द रेट ऑफ इवेपोरेशन बिकम्स इक्वल टू द रेट ऑफ कंडेंसेशन एट अ पर्टिकुलर पॉइंट, एट अ पर्टिकुलर टेम्परेचर, है ना, if the temperature remains constant. And at that time, when the equilibrium is attained, the vapors present above the surface of the liquid always exert pressure on the surface of the liquid. Obviously, because as we know that gases always exert pressure. So the pressure exerted by the vapors in equilibrium with the liquid at a given temperature is known as nothing but vapor pressure. So I am writing here the definition of the vapor pressure. The pressure, hope you all have understood, the pressure exerted by vapors in equilibrium with liquid at a given temperature is called vapor pressure. Understood? Okay, at a given temperature should be constant. If you increase the temperature, then the vapor pressure also increases, so it will change. So temperature should be constant. That is known as vapor pressure. Okay, now on what factors the vapor pressure depends? The vapor pressure depends upon, I am writing the short form here, but you are not supposed to write the short forms in exams also. Okay, so vapor pressure depends upon the two factors only. First one is temperature, second one is nature of liquid. Nature of liquid: if the liquid is having more interparticle force of attraction, then obviously vapor pressure is less, will be less. Okay, if the liquid is having lesser or weaker interparticle forces of attraction, then the vapor pressure is will be obviously greater. Okay, so it depends upon the type of or nature of liquid that we are considering. Now I'll tell you some examples in nature of liquid. For example, if we have three types of liquids: water, alcohol, मतलब ethanol, ethyl alcohol, and ether. Suppose diethyl ether or ether. At suppose temperature is constant, that is 20 degrees Celsius. At 20 degrees Celsius, water will show the vapor pressure of 17.5 mm of Hg. As you know that this is the unit for measuring pressure. Okay, and ethyl alcohol, that is alcohol, always show 43.9, and it always show 42.2, very high in case of ether, because it has very weak interparticle forces of attraction. So nature of liquid matters in terms of vapor pressure. Okay, now next, the most important one is factor is on which the vapor pressure depends is temperature. As the temperature increases, the temperature is always, or we can say that the vapor pressure is always directly proportional to temperature, because as we know that as the temperature increases, the rate of evaporation also increases, so there will be more vapors in the container, so there will be more vapor pressure. Understood? So as the temperature increases, the vapor pressure of the liquid always increases. Okay, clear? So this is how, because as we how will we explain it? That we will explain it like that: if the temperature of the liquid increases, its rate of evaporation also increases, so as a result the vapor pressure also increases. Okay, now there is a relation also. If vapor pressure of a liquid is known at a temperature, सपोज उसका वेपर प्रेशर हमें एक टेम्परेचर पे पता है, सो न्यूमेरिकल्स के लिए बता रहा हूँ आपको, एक इक्वेशन है ये, एंड देयर इज नॉट डेरिवेशन ऑफ दिस इक्वेशन, वी हैव जस्ट क्रैम इट. ओके, इट कैन बी कैलकुलेटेड एट अनदर टेम्परेचर. सपोज हमें एक टेम्परेचर पर पता है कि उसका वेपर प्रेशर कितना है, तो हमें दूसरे टेम्परेचर पर निकालना हो. सपोज वाटर पता है हमें कि 20 डिग्री सेल्सियस पे इतना होता है, और उन्होंने कह दिया कि बताओ उसका वेपर प्रेशर 100 डिग्री सेल्सियस पे कितना होगा. तो वी कैन से इट कैन बी calculated at other temperature using an equation which is known as Clausius-Clapeyron equation, and this equation is log P2 upon P1. P2 is second pressure that we have to find. P1 is the pressure which is given, is equal to delta H is enthalpy change. We have done it in the +1 class also. 2.303 RT. R is gas constant, T is temperature which is fixed. Okay, but here T will not be written. T1 minus T2. Okay, so this is the first temperature that we are provided with, second temperature that we have also given. ठीक है, सो हमें ये पता होगा, ये पता होगा, आर हमें पता है गैस कांस्टेंट होता है, डेल्टा एच पता होगा हमें, तो हमें क्या निकालना होगा, P2 निकालना होगा. तो दिस इज द एक्चुअल इक्वेशन फॉर कैलकुलेटिंग द वेपर प्रेशर एट एनी अदर टेम्परेचर इफ द वेपर प्रेशर एट वन टेम्परेचर इज गिवन. Understood? So this is how we can calculate the vapor pressure of any liquid at different temperatures. Okay, so this is all about the vapor pressure. Now on vapor pressure we have a law which is of very much importance. The next topic is Raoult's law. Raoult's law it is of very much importance बेटा, ये बहुत इंपॉर्टेंट है बोर्ड एग्जाम के लिए ये लॉ. ठीक है, तो Raoult's law, there is a French scientist known as Francois Marie Raoult. इसने एक लॉ दिया था वेपर प्रेशर ऑफ लिक्विड के ऊपर. He gave a general statement that when a non-volatile solute like sugar, salt, urea, etc. anything is dissolved in a liquid, then it is observed that the vapor pressure of the liquid is lowered. Clear? इसने बेटा कहा था कि कोई भी अगर नॉन वोलेटाइल सॉल्यूट जैसे शुगर हो गई, सॉल्ट हो गया, यूरिया हो गया, अगर हम उसे डिसॉल्व करेंगे किसी लिक्विड में जो कि वोलेटाइल है, चाहे पानी है, कुछ वाटर है, एनीथिंग, तो ये क्या होगा, उस लिक्विड का वेपर प्रेशर हमेशा डिक्रीज होगा. दिस इज रॉल्ट्स लॉ. सो अकॉर्डिंग टू दिस लॉ वी कैन से दैट व्हेन a non-volatile solute like sugar, salt, etc., urea you can also mention it, is dissolved in a liquid, then it is observed that the vapor pressure of liquid is lowered. तो देखा गया है कि वेपर प्रेशर ऑफ लिक्विड क्या हो जाएगा, लोअर हो जाएगा. ऑब्वियसली व्हाई, बिकॉज द डेंसिटी ऑफ द लिक्विड इंक्रीजेस एंड अकॉर्डिंग टू ग्राम्स लॉ एज द डेंसिटी इंक्रीजेस क्या होगा, rate of evaporation decreases and so the vapor pressure also decreases. Understood? Okay, so if I'll show you by making a diagram. Suppose we have a closed container in which in a beaker we have taken a pure solvent. That is, for example, water is taken, only water is taken suppose. Then the vapor pressure क्या होगा, यहाँ पे वेपर्स होंगे बहुत सारे, तो वेपर प्रेशर क्या होगा बेटा, हाई होगा, हाई वेपर प्रेशर. Understood? But if in a same closed container in this water in this beaker containing water, if we will add some sugar or salt and dissolve it in it and again keep it in this closed container, then what will happen? Suppose this is solution, suppose salt plus water, then what will happen? It will also convert into vapors, but the vapor pressure gets lowered, low vapor pressure होगा तब. Okay, clear? So diagrammatically you can show it like this: high vapor pressure, low vapor pressure होगा solution का. So lowering of vapor pressure can be explained as follows. How will you explain the lowering? कैसे हुआ lowering, क्यों हुआ low vapor pressure, उसका क्या reason है उसका? तो first, as I have told you, first we can say in explanation that according to Graham's experiment or Graham's law, Graham's law के अकॉर्डिंग क्या था, the rate of evaporation is inversely proportional to the square root of density. As the density of liquid increases, the rate of evaporation decreases, so hence the vapor pressure also decreases, है ना. तो फर्स्ट हम कह सकते हैं कि ग्राहम लॉ के अकॉर्डिंग उसका वेपर प्रेशर कम हो जाएगा. और सेकंड इज नथिंग बट व्हाट, रॉल्ड्स लॉ. प्लीज रिमेंबर द स्पेलिंग्स ऑफ रॉल्ड्स लॉ, बिकॉज ऑलवेज बच्चे जो हैं इसमें गलती करते हैं इसको, इसकी स्पेलिंग लिखने में. RAOU है बेटा, रॉल्ड्स लॉ, RAOULT apostrophe. Okay, Raoult's law के अकॉर्डिंग द वेपर प्रेशर ऑफ सॉल्यूशन कंटेनिंग नॉन वोलेटाइल सॉल्यूट क्या होगा, हमेशा डिक्रीज होगा, है ना. क्लियर? तो Raoult's law के अकॉर्डिंग ये था, डिक्रीज होगा हमेशा. एंड अकॉर्डिंग टू Raoult's law, जो एक्चुअली Raoult's law आया उसके बाद, तो वो क्या है, सो इससे एक Raoult's law ने मैथमेटिकल एक्सप्रेशन बनाया, क्या बना उसका, अकॉर्डिंग टू Raoult's law, according to Raoult's law, the vapor pressure of a solution containing non-volatile solute is directly proportional to the mole fraction of solvent. The vapor pressure of solution containing non-volatile solute is directly proportional to the mole fraction of solvent. Why? Suppose now I'll again make some diagram to better understand this topic. Suppose we have a closed container in which water is kept or a liquid is kept. ठीक है. So here all the molecules on the surface is of solvent only. Suppose this is solvent. सारे मॉलिक्यूल्स किसके होंगे? सॉल्वेंट के होंगे. अगर हम ये इवेपोरेट होगा तो सारे के सारे मॉलिक्यूल्स इवेपोरेट हो जाएंगे. तो मैक्सिमम मॉलिक्यूल्स क्या इसके होंगे? ऊपर वेपर में किसके होंगे? सारे सॉल्वेंट के होंगे. तो ऑब्वियसली द वेपर प्रेशर शुड बी हाई होगा, है ना. बट नाउ इफ वी आर टेकिंग सॉल्यूशन हेयर इन दिस सॉल्ट एंड वाटर, दैट इज सॉल्यूशन, जिसमें हमने नॉन वोलेटाइल सॉल्यूट ऐड कर दिया. तो अभी क्या होगा? कुछ मॉलिक्यूल्स को तो किसके होंगे? सॉल्वेंट के ही होंगे अगेन. बट कुछ स्पेस, सम स्पेस इज ऑक्युपाइड बाय, विल बी ऑक्युपाइड बाय द मॉलिक्यूल्स ऑफ सॉल्यूट ऑल्सो, नॉन वोलेटाइल सॉल्यूट. ठीक है. सो सपोज टू से दिस, इफ अगर पहले एक बार में सरफेस में से सपोज 100 मॉलिक्यूल्स ऑफ सॉल्वेंट बाहर जाते थे, इवेपोरेट होते थे, मतलब वेपर्स में कन्वर्ट होते थे, तो अभी सरफेस पे 100 मॉलिक्यूल तो अवेलेबल है ही नहीं, क्योंकि कुछ स्पेस ऑक्युपाई कर ली है किसने? सॉल्यूट मॉलिक्यूल्स ने. तो अभी अगर पहले एक सेकंड में 100 मॉलिक्यूल, सपोज कर रहे हैं हम ये, अगर सपोज एक सेकंड में 100 मॉलिक्यूल्स इवेपोरेट होते थे सॉल्वेंट के, तो अभी कितने होंगे? सिर्फ 60, 70, 50, डिपेंड्स अपॉन द अमाउंट ऑफ सॉल्यूट वी आर एडिंग. ठीक है. सो अभी जो वेपर प्रेशर है वो बहुत क्या होगा? कम होगा, लो होगा, बिकॉज सम स्पेस एट द सरफेस इज ऑक्युपाइड बाय, विल बी ऑक्युपाइड बाय द सॉल्यूट, नॉन वोलेटाइल सॉल्यूट मॉलिक्यूल्स. सो वेपर प्रेशर क्या होगा बेटा? लो होगा. सो दिस जो वेपर प्रेशर होगा यहाँ पे वो किसकी वजह से होगा? बिकॉज ऑफ द सॉल्वेंट ओनली ना, बिकॉज सॉल्वेंट इज वोलेटाइल बट सॉल्यूट इज नॉन वोलेटाइल. सो अकॉर्डिंग टू Raoult's law is saying that the vapor pressure of solution, जो solution का vapor pressure है, जो इसमें था solution का vapor pressure है, containing non volatile solute is directly proportional to the mole fraction of solvent. मतलब solution में जितना ज़्यादा solvent होगा उसी पे डिपेंड करेगा vapor pressure solution का. जितना solvent कम होगा उतना vapor pressure कम होगा solution में, और जितना solvent ज़्यादा होगा उतना vapor pressure क्या होगा? ज़्यादा होगा. Understood? So it always depends upon the mole fraction of solvent only. So mathematically we will write it, we will express it like this: P is the vapor pressure of what? Solution. ठीक है. और it is directly proportional to the mole fraction of solvent, because A is always considered as solvent and B is always considered as a solute. बेटा A हमेशा सॉल्वेंट को डिनोट करता है और बी हमेशा सॉल्यूट को डिनोट करता है. ये हमने पहले भी किया हुआ है, तो आपको मैं दोबारा से बता रहा हूँ ये फॉर नॉलेज, फॉर जस्ट टू रिमेम्बर इट. ओके, क्लियर. सो अकॉर्डिंग टू Raoult's law, द वेपर प्रेशर ऑफ सॉल्यूशन इज डायरेक्टली प्रोपोर्शनल टू द मोल फ्रैक्शन ऑफ सॉल्वेंट. ठीक है. तो सॉल्यूशन कंटेनिंग नॉन वोलेटाइल सॉल्यूट. नाउ आफ्टर रिमूविंग दिस साइन वी कैन राइट K here. Where K is known as a constant. Okay, clear? K is known as a constant. Now if suppose if XA is equal to 1, अगर x से 1 होगा बेटा, then XB क्या होगा? 0 होगा. इसका मतलब पता है क्या हुआ? कि जो सॉल्यूशन है उसमें सिर्फ क्या है? सॉल्वेंट ही है, सॉल्यूट 0 है. XB means mole fraction of solute is equal to 0. So there is no non-volatile solute is added in the solvent. So there is only a solvent. ठीक है. If XA is equal to 1, then what will happen? Then XB is equal to 0. Then it is pure solvent only. Then it is, मतलब this condition always applied for pure solvent. मतलब in the solution in which no solute is added. Now, and the vapor pressure of the pure solvent or solution and a solvent will be same. Obvious, vapor pressure same होगा. अगर हम बात करें कि एक solution है उसमें सिर्फ solvent ही है, सोल्यूट तो है ही नहीं, तो सोल्यूशन का जो टोटल वेपर प्रेशर होगा तो वो किसके बराबर होगा, जो सॉल्वेंट का खुद का वेपर प्रेशर है। ओके क्लियर, सो दैट इज वी कैन से दैट फ्रॉम दिस P is equal to P naught. P is the vapor pressure of solution and P naught is the vapor pressure of solvent. क्लियर, सो ये दोनों इक्वल होंगे। अगर ये कंडीशन होगी प्योर सॉल्वेंट लेंगे तो वेपर प्रेशर सॉल्वेंट का जितना होगा वही वेपर प्रेशर किसका होगा, सॉल्यूशन का होगा। सो वी कैन से दिस। ओके क्लियर, सो ये आ जाएगा हमेशा हमारे पास। क्लियर, ओके नाउ सो अगर ये दोनों इक्वल हैं तो इस फ्रॉम फर्स्ट इक्वेशन और आई एम राइटिंग हियर ओनली फ्रॉम फर्स्ट क्या आएगा, P इज इक्वल टू P नॉट इज इक्वल टू क्या आ जाएगा, K और XA कितना है हमारे पास 1, तो क्या करेंगे 1, तो P नॉट इज इक्वल टू क्या आ जाएगा K, दैट इज ऑलवेज कांस्टेंट। क्लियर, सो वेपर प्रेशर ऑफ प्योर सॉल्वेंट इज ऑलवेज कांस्टेंट एंड मैक्सिमम, ये भी याद रखना हमेशा। ओके क्लियर, सो अगर P नॉट इज इक्वल टू K और K इज इक्वल टू P नॉट आ गया बेटा, सो अगर हम इसको इसमें पुट करेंगे इस इक्वेशन में, तो दिस इक्वेशन कैन बी रिटन एज क्या, P इज इक्वल टू P नॉट XA। सो दिस इज द एक्चुअल एक्सप्रेशन ऑफ Raoult's law that you have to remember for numericals also and for further chapter also. P is equal to P naught into XA, that is vapor pressure of solution is equal to the product of partial vapor pressure of pure solvent and mole fraction of the solvent. Clear, okay, so according to Raoult's law, or we can say that Raoult's law can also be defined as it is defined as the vapor pressure of solution is equal to the product of vapor pressure of pure solvent and mole fraction, its mole fraction and mole fraction of solvent. So this is the actual expression or actual definition, we can say that for Raoult's law, that is P is the total vapor pressure of solution and P naught is the vapor pressure of solvent. Solvent is A, so we can also write it as PA naught into XA और X solvent के लिए। ठीक है बेटा, so this equation you have to remember, you must have to remember it. Clear, done. This is only for non-volatile solute. If the solute is non-volatile, then total pressure is equal to PA naught XA. Okay, but now Raoult's law for RAOUL, please remember the spellings. Okay, Raoult's law for volatile solutes. If the solute is volatile, now what will happen? मतलब पहले तो हमने किया था अगर सोल्यूट नॉन वोलेटाइल है और सॉल्वेंट वोलेटाइल है तो हमारे पास रिलेशन ये बनेगा। बट अगर सोल्यूट भी वोलेटाइल है तो क्या होगा, मतलब सोल्यूट भी लिक्विड स्टेट में है, लिक्विड सॉल्यूशंस हैं दोनों, तो क्या होगा, तो इफ टू volatile liquid solutions are mixed to form solution, then the vapor pressure will be composed of both components. Obvious है, अगर हमारे पास एक liquid, now listen, suppose we have two containers, in it this a liquid A, a liquid B, this is solute, suppose B is solute and A is solvent. ठीक है, so in this liquid the vapor pressure is only of PA naught, that is pure, PA naught means pure solvent, this is also solute, so in this container the vapor pressure is of only because of only B, so it is PB naught, it is also maximum here, it is also maximum here because this is also volatile, this is also volatile. ठीक है, अगर हमने सपोज इनको मिक्स कर दिया, दोनों को क्या कर दिया, मिक्स कर दिया, तो मिक्स करने के बाद दो एक सोल्यूशन में आएंगे, टोटल एक कंटेनर में डाल दिए दोनों हमने, इसमें A भी है और हमारे पास B भी है, तो ऊपर जो वेपर्स बनेंगे इसके इन द कंटेनर इट वुड बी ऑफ बोथ। इसमें PA प्रेशर जो होगा वो PA की वजह से भी होगा और PB की वजह से भी होगा। दिस इज PA इज प्रेशर टोटल सॉरी हाँ प्रेशर ऑफ वेपर प्रेशर ड्यू टू कंपोनेंट A, PB इज वेपर प्रेशर ड्यू टू कंपोनेंट B इन अ सॉल्यूशन। ये सॉल्यूशन में है। PA नॉट और PB नॉट क्या था बेटा, ये अकेले सॉल्वेंट के थे, मतलब इनके प्योर फॉर्म में थे। PA PB क्या है, इनके सॉल्यूशन में है। ठीक है, ओके। सो अकॉर्डिंग टू रॉड सपोज the mole fraction of A is XA in this solution and B is XB in the solution of components A and B. ठीक है, suppose let XA and XB are the mole fraction of components A and B in the solution and PA PB are पार्शियल वेपर प्रेशर्स। पार्शियली बोलेंगे क्योंकि ये कंप्लीट प्योर तो है नहीं, तो कुछ पार्ट इसकी वजह से है प्रेशर का, कुछ पार्ट प्रेशर का इसकी वजह से है, तो वी विल कंसिडर इट एज पार्शियल प्रेशर्स। ओके, PA and PB are the partial vapor pressure of the components and PA naught PB naught are the vapor pressure of the pure components, मतलब when they are in the pure state। PA अकेला A था, अकेला B था, तो PA naught और PB naught हो गया। सो अकॉर्डिंग टू रॉड्स लॉ, अगर हम रॉड्स लॉ इस पे अप्लाई करें तो क्या होगा अकॉर्डिंग टू रॉड्स लॉ, अगर हम अकेला A पे अप्लाई करें तो अकॉर्डिंग टू रॉड्स लॉ क्या था कि इसमें सॉल्यूशन में जो प्रेशर है A की वजह से वो क्या होगा, हमेशा इसका जो प्योर फॉर्म है इनटू इट्स की क्या होगी, मोल फ्रैक्शन, है ना। एंड PB नॉट जो प्रेशर P की वजह से है यहाँ पे, तो वो क्या होगा, सॉरी PB ये नॉट नहीं आएगा, PB नॉट इनटू क्या आएगा बेटा XB, ये होगा PB की प्रेशर सोल्यूशन में PB की वजह से प्रेशर। एंड नाउ टोटल वेपर प्रेशर क्या होगा हमारे पास, टोटल वेपर प्रेशर इन अ सॉल्यूशन कितना होगा, P दैट इज इक्वल टू PA प्लस PB। टोटल प्रेशर तो यही होगा ना, कि टोटल प्रेशर हमारे पास इसका सोल्यूशन का कितना है, PA प्लस PB है। ठीक है, सो on putting the values of PA and PB in this equation we will get PA naught XA plus PB naught XB, है ना। so this is the actual expression for Raoult's law for volatile solutes, clear, okay, and we will also convert it like this, as we know that that is because XA plus XB is equal to 1, this implies that XA is equal to 1 minus XB, ये आ जाएगा हमारे पास। तो अगर हम यहाँ पे पुट कर दें XA की वैल्यू तो क्या आएगा हमारे पास, PA नॉट 1 माइनस XB प्लस PB नॉट XB। सो इन टर्म्स ऑफ ओनली XB आ गए, मतलब मोल फ्रैक्शन ऑफ सॉल्यूट की टर्म्स में आ गया सारा एक्सप्रेशन, तो इसको हम ऐसे मेंशन कर सकते हैं। सो दिस इज द एक्सप्रेशन। सो वी हैव डन टू एक्सप्रेशन फॉर Raoult's law now टुडे, दैट फर्स्ट इज वन इज फॉर नॉन वोलेटाइल सॉल्यूट्स। For non-volatile solute, the total pressure of the solution is always equal to the vapor pressure, pressure for pure component, मतलब solvent and its mole fraction, मतलब solvent पर डिपेंड करेगा सिर्फ। बट फॉर volatile solutes, अगर solute volatile है तो total pressure depends upon both components A and B also, clear, done। So this is how it happens। Okay, so that's all for the day. In the next lecture we will do the comparison between Henry's law and Raoult's law and the relation between Dalton's law and the Raoult's law. Okay, first I will explain you the Dalton's law, then we will do the relation between these two and the comparison between Raoult's law and the Henry's law and ideal solutions, what are non-ideal solutions. The next lecture is of very much importance, please listen it carefully and okay, so that's all for the day. I'll give you some assignments or worksheets on this, please revise it carefully and please do the derivations at on your fair notebooks and practice it a maximum time, because it is very much important. Royal's law is of very much importance for this chapter and for board exam also. This is the basic that I have told you today. Okay, so bye bye, take care, stay safe, stay home.